Have you ever looked up at the night sky and wondered if we're alone? The vast expanse above us, filled with countless stars, has always sparked human curiosity and imagination. It's a question that has not only intrigued casual stargazers, but has also puzzled scientists and philosophers for decades. This curiosity has led to the formulation of what's known as the Fermi paradox. Named after the physicist Enrico Fermi, the paradox delves into the apparent contradiction between the high probability of extraterrestrial life and the lack of evidence for or contact with such civilizations. Simply put, the Fermi paradox asks, if the universe is so vast and old, with countless opportunities for life to arise, then why haven't we found any evidence of other civilizations? This question becomes even more intriguing when we consider the sheer number of stars and planets out there. To understand the paradox, let's consider the sheer scale of the universe. Our galaxy, the Milky Way, contains billions of stars, many of which are orbited by planets. These planets vary in size, composition, and distance from their stars, creating a diverse array of environments. And many of these planets lie within the habitable zone, where conditions might be just right for liquid water and potentially life to exist. This zone, often referred to as the Goldilocks zone, is neither too hot nor too cold, making it ideal for life as we know it. Estimates suggest there could be billions of habitable planets in our galaxy alone, and the universe contains billions of other galaxies, each with its own potential for hosting life. The numbers are truly staggering when you think about it. The universe is also incredibly old, around 13.8 billion years. That's plenty of time for life to evolve and for civilizations to rise and spread across the cosmos. Given this immense timescale, it's conceivable that many civilizations could have emerged and potentially even disappeared. Even if interstellar travel is slow, a civilization could theoretically colonize the entire galaxy in a few million years, a blink of an eye on cosmic timescales. This idea suggests that advanced civilizations could have spread far and wide by now. So with all these opportunities and plenty of time, where is everyone? This is the heart of the Fermi paradox. The silence we observe is deafening, and it raises profound questions about our place in the universe. Let's explore some possible explanations. Could it be that we are truly alone? Or is there something we are missing in our search for extraterrestrial life? One idea is the rare Earth hypothesis, which suggests that the conditions required for complex life to evolve are incredibly rare. This hypothesis posits that while microbial life might be common in the universe, the leap to complex multicellular organisms is a monumental one. The specific conditions that allowed life to flourish on Earth might be so unique that they are unlikely to be replicated elsewhere. It's not enough to just have a habitable planet. You also need the right kind of star, a stable orbit, a protective moon, plate tectonics, and a whole host of other factors. For instance, our Sun is a relatively stable star, providing consistent energy without the violent flares that could strip away a planet's atmosphere. Our Moon plays a crucial role in stabilizing Earth's tilt, which in turn regulates our climate. Earth might be unique in having all these conditions perfectly aligned, making it the only planet in our galaxy or even the universe where complex life has arisen. The presence of liquid water, a magnetic field that shields us from harmful cosmic radiation, and the right chemical ingredients all contribute to this delicate balance. Another possibility is the Great Filter. This idea suggests that there's some kind of barrier that prevents most, if not all, life from reaching a certain stage of development. This filter could be a series of improbable events or a single insurmountable challenge that stops life from advancing. This barrier could be anything from the formation of single-celled life to the evolution of intelligence or the development of advanced technology. Each step in the evolutionary ladder presents its own set of challenges, and the Great Filter could be lurking at any one of these stages. If the Great Filter is behind us, it means that we've already overcome the odds and that life is rare because it struggles to get to where we are now. This would imply that humanity is exceptionally fortunate, having navigated through the most difficult stages of development. But if the Great Filter is ahead of us, it means that there's some future challenge that awaits us, something that will likely wipe us out. as it has done to countless other civilizations before us. This could be a natural disaster, a self-inflicted catastrophe, or an unforeseen cosmic event. Perhaps advanced civilizations tend to destroy themselves, either through war, environmental catastrophe, or some other means. The pressures of technological advancement and resource consumption might lead to inevitable self-destruction. Or maybe the resources required for interstellar travel are so vast that no civilization can overcome the challenge. The energy and materials needed to traverse the stars might be beyond the reach of any society, no matter how advanced. These civilizations might face insurmountable obstacles, whether they are environmental, technological, or social, preventing them from making the leap to interstellar travel. In the vast expanse of the universe, Earth stands out as a rare gem, a cradle of life in an otherwise hostile cosmos. As we look to the stars, we must consider both the fragility and the resilience of life, and the unique set of circumstances that have allowed us to thrive. Another possibility is that other civilizations are out there, but they're deliberately avoiding us. This is known as the zoo hypothesis, which suggests that advanced civilizations are observing us, like animals in a zoo, but they don't want to interfere with our development. Perhaps they know something we don't, and they realize that it's dangerous to reveal themselves to other civilizations. It's also possible that we're simply not listening in the right way. Our current search for extraterrestrial intelligence, or SETI, relies on detecting radio waves or other electromagnetic signals. But perhaps advanced civilizations communicate in ways that we don't yet understand, using technologies that are beyond our current capabilities. Or maybe the signals are simply too faint to detect across the vast distances of space. We've only explored a tiny fraction of the galaxy, so it's possible that signals are out there, but we haven't found them yet. Then there's the simulation hypothesis, the mind-bending idea that our entire reality is a computer simulation. This theory suggests that everything we experience, from the smallest atom to the vastness of space, is part of a complex program designed by an advanced civilization. If that's the case, then the absence of other civilizations could simply be a programming choice. The creators of this simulation might have decided to isolate us, making us believe we are alone in the universe. The simulators might not want us to discover other life, or they might be running the simulation for some other purpose that we can't comprehend. Perhaps they are studying our behavior, or maybe they have ethical reasons for keeping us in the dark. So what's the answer to the Fermi paradox? We don't know. But the search for extraterrestrial life is one of the most exciting and important scientific endeavors of our time. Scientists are using advanced technology to scan the skies, hoping to find signals or signs of life beyond Earth. If we find life elsewhere in the universe, it would change everything. It would be a monumental discovery, reshaping our understanding of biology, evolution, and our place in the cosmos. It would give us a new perspective on our place in the cosmos, and could potentially solve some of humanity's greatest challenges. We might learn new technologies, gain insights into sustainability, or even find new allies in the quest for knowledge. The Fermi paradox reminds us that we don't have all the answers. It encourages us to keep exploring, keep questioning, and keep searching for the truth. The journey itself is as important as the destination. What do you think? Do you believe we are alone, or is there something more out there waiting to be discovered? Let us know your thoughts on the Fermi paradox in the comments below. Your perspective could add a new dimension to this fascinating discussion.